Today we're going to look at some mole to gram conversion problems. Before we do that, I want to go over the molar mass introduction activity that you had and just kind of talk about that a little bit. So you were given, you needed your periodic table and calculator. You had Google Slides where I put a sample that was in a container on the scale, and you had to fill in this column here from the Google slide. So you had to take the mass of 1 mole of the sample, the mass of the container, subtract, and it gives you this mass here. The masses in green here, or the numbers in green were from the periodic table. So what I wanted you to see was that these last two columns are basically equal. Now, there's a slight difference because the scale I use to take the pictures is an electronic balance, and it only goes one place behind the decimal point. Many of the numbers you saw on the periodic table have 2 places behind the decimal point, so they were slightly different, but for the most part, these numbers are equal. And so what you were supposed to get from this activity is that on the periodic table, the average atomic mass listed on the periodic table is equal to the molar mass. So molar mass is how many grams per 1 mole of the sample. And so when I made these samples, so for example, when I made the sample for aluminum, I measured out I tried to measure out 26.99 grams of aluminum and put it in the container, because that way I have a 1 mole of aluminum. I can't count out 6.022 times 10 to the 23rd atoms of aluminum, but I can look at the periodic table, know that that number is how many grams are in 1 mole for any element on the periodic table. So copper is another one. It's in our phenomena. 1 mole of copper is 63.55 grams. So when you look at the periodic table for molar mass, you want to make sure you have 4 sig figs from the periodic table. So what I want you to do now is get out your green periodic table, get out your calculator. We're going to do some calculations using molar mass. And if you need a moment to go get those items, just pause the video and come back. And so let's talk about what we already went over in a previous video. We converted from atoms to moles. We used Avogadro's number, and we can convert from how many atoms there are in a sample to moles. Now, in a lab, we don't have a device to measure moles. So what we need to do is we need to be able to convert from moles to grams. Or grams to moles. The conversion factor for this is molar mass. The units for molar mass are grams per mole or 1 mole for how many grams. It's from the periodic table. And you always want to use the green periodic table that I gave you. If you need another copy, they're available in the course materials, so you can print one off. I will always provide you one for tests and quizzes that you come in person to take. You do not have to memorize the molar masses. And you want to have 4 sig figs. So we're going to do a conversion. We have 126 grams of iron. This is what we have. We want to find how many moles of iron are in that many grams. So I'm going to start with a number in units given. Oops. I'm going to go back to my blue pen. There we go. 126 grams of iron. Now I'm going to put a placeholder of 1 here, just so that you don't write anything there. That's just a placeholder. I set up my railroad tracks. Whatever units I put here, the units I start with should go down here. I'm trying to find moles of iron, so those should go on the top of my conversion factor. And you can see in my flowchart at the top, I started with grams. I started here, and I'm going to go to here. The units I have are moles and grams. This is molar mass. I didn't put any numbers in. You just look at the units moles and grams, and that tells you it's molar mass. The only other conversion factor we're using is Avogadro's number, which is moles and atoms. Wherever it says moles, there's 1 mole. This is the definition of molar mass, 1 mole. And then I look at my periodic table. Iron is Fe, and that's 55.85 grams. I do recommend that you learn the names and symbols for the first 40 elements. It'll make it easier for you. I'm not going to test on it this year. But for example, knowing that iron is Fe will make it easier for you when you're using your periodic table. So you're going to multiply the top, multiply the bottom, and divide. And so what you would get here is 126 divided by 55.85. You want to round for correct sig figs. This number here is 3. The number on the bottom has 4. So I need 3 sig figs, 2.26. As far as units, when you multiply the top and multiply the bottom and then divide, units diagonal cancel. And so I get 120 or 2.26 moles of iron. So the next problem we're going to do, we're going to start from moles and go to grams. We're going to go this direction. The first problem, we went this direction. So we're going to go moles to grams in the next example. So I'm going to start with 0.42 moles of aluminum, setting up my railroad tracks. I'm going to put a 1 as a placeholder. The units here are going to go to the bottom. So moles of aluminum go here. That's what I'm looking for here. I want grams. The units I want go on the top. And again, I'm looking at the units. I have moles and grams, which is molar mass. It doesn't matter if they're on the top, they're the bottom. All you're looking for is grams and moles. And the definition of molar mass is how many grams are in 1 mole. So for aluminum, there are 26.98 grams of aluminum for 1 mole of aluminum. So pause the video and do this calculation. You're going to multiply the top, multiply the bottom, and divide. So pause the video so make sure that you get the correct answer before you see the correct answer that I give you. So when I do this, these units cancel. So I'm left with the units I want, which are grams of aluminum. I have 2 sig figs. I have 4 sig figs, so my units should have 2 sig figs. So it's 11 grams of aluminum. And that should make sense because we have less than a mole of aluminum, so we should have less than 26.98 grams. We have about a little less than half a mole, so this number should be less than half of the mass of aluminum. In our next video, our next Zoom meeting on Friday, we will go through how to combine the 2 conversion factors so that we can convert from atoms to moles. If you have any questions, please send me a message through Schoology. Or you can also attend the next session of office hours and we can discuss these problems and I'll go through some more with you.